Hello everybody, my name is Suhad Al-Mukhtar, the WATERAGRI Project Data Manager. Today, I'm presenting to you about the wetland system as a proposed solution by WATERAGRI Project, which is funded by European Union Horizon 2020 Research and Innovation Program and coordinated by Lund University in Sweden. First of all, we need to understand what wetland systems are. Wetlands are dynamic aquatic ecosystems found all over the world. A wetland is an area of land that is saturated with water either permanently or seasonally. Wetlands were concluded to be one of the most suitable technology in terms of pollutant removal and have advantages of low maintenance costs and required energy. Wetlands were like natural filters. For example, this figure shows that wetlands are dissipated stream energy, slow the movement of water over land, and trap nutrients, sediments, and other pollutants before they can enter the rivers and streams. In many ways, wetlands in our region work almost as hard as farmers do. The question now is why wetlands are important. Wetlands are important because they provide many ecosystem services. For example, here we can see that wetlands may offer provision services, support services, culture services, as well as regulatory services. Wetland could be naturally available or could be constructed. Constructed wetlands are man-made systems designed and constructed to treat wastewater using the natural processes typical of natural wetlands. These natural processes are an interaction and combination of wetland plants, soil, and microbial life. Constructed wetlands can be classified according to water flow regime 2, surface flow constructed wetland system, and subsurface flow constructed wetland system. For the surface flow 1, it could be subsequently classified according to the type of plants used in the system, as shown in the figure. Furthermore, constructed wetlands with subsurface flow may be classified according to the direction of flow into horizontal subsurface flow constructed wetland system and vertical subsurface flow constructed wetlands, as shown in this schematic of subsurface flow constructed wetland figure. Constructed wetlands consist of three main elements, in which the first one is the constructed wetland macrophytes. Macrophytes can absorb pollutants from the wastewater and accumulate them in their tissue, as well as responsible for transferring oxygen from their roots, providing aerobic conditions to enhance the contaminant degradation in the system. The second element is the constructed wetland substrate. Wetland media could be sand, gravel, rock, or organic material such as soil and compost, which provide the primary support for the wetland plants and microorganism growth, in addition to its impact on system hydrology mechanism, as well as remove contaminant from the wastewater. The third constructed wetland element is the microorganisms. Microbial community growth in the constructed wetland plays a vital role in eliminating various types of wastewater pollutant during biological process, in addition to the physical processes, chemical transformations, and the uptake by macrophytes in the system. Wetlands have been used for agriculture for thousands of years, as they provide a range of valuable ecosystem services, such as the provision of food and clean water, the retention of soil, and cycling of nutrients. In this figure, we can see a case study of using constructed wetlands to irrigate fields for treated effluent reuse. The European Union considers wetland ecosystem as an important part of Europe's biodiversity. For example, we can see here some of wetland projects in various European countries, such as Austria, Hungary, and Germany, which were funded by the European Union. The European Union has been a major provider of funds for wetland conservation projects, both within and outside the Union. In Sweden, Lund University is responsible for the farm constructed wetlands as WATERAGRI solution in Gardestanga location for water retention and nutrient recovery. Note that farm constructed wetlands allows for capital cost saving of at least 70% in comparison to traditional technology, in addition for running cost saving of at least 90%. The case study trials by Lund University is located in Gardestanga with land use of 200 hectares of organic and 800 hectares of conventional farmland. The key interventions are dikes and wetlands, and the expected output are improved soil health, reduced leaching of nutrients, and decreased carbon dioxide emission. Thank you very much for listening and looking forward to collaborate with project member and stakeholder. For more information, please contact Dr. Suhad Al-Mukhtar via email of suhad.suhad81@yahoo.com or suhadsuhad81@gmail.com.